Hello everyone and welcome to episode 5 of our C++ Mastery series. Now in this series we are going to look at input and output specifically to the console. Throughout the series we have been using stdcout and stdcin without actually explaining what is going on with those commands. Now we can think of stdcout and stdin as our pipe connected to our terminal, in this case the console output, okay? And with this pipe, whenever we type cout, we are basically sending things to the terminal to be displayed to us, right? With stdcin, all right, we want information to come to us from the user using the terminal. So this left stream operator is filling up this pipe to the terminal with this hello. And then we could again string other things over here like yes or whatever you want to put here. I don't know, a little smiley face. And then this is again sending that to that cin or cout pipe, that is going to be sent to the terminal, but it's not sent yet to the terminal. Only when that pipe is flushed via std end line or via the console flushing it itself, will it actually display it to the console. All right. Over here we have different types, like age is an int, height is a double, initials a char, is students a bool, name is a string, and we can print these as follows. For age, an integer, it will just print nicely. For height, it will print like this, 5.11 nicely, which is a double. For initial, it's a char, will also print nicely. But remember, for boolean, this will treat it as an int, where it will print 1 for true and 0 for false. So we have to use std bool alpha mode to actually print it as a boolean, in this case true. And then name, which is a string, will also just print nicely to the console. Now, it's also important to remember that if you make a std uint 8 and we set this equal to like 1, let's say, or this a for example, and we try to print a, this, what we will get is we might expect to get 1, but really it's an unsigned int of 8, so it will treat it as a char and it will print a char to the console. Okay, so yeah, I don't know what the first ASCII character is, but that will be printed. It's not going to be 1, it's going to be some weird character that you didn't expect. So you actually should cast this to an int, or static cast it, not C-style cast if you want, to get the actual value, okay? You can also chain together the output string operator, or the output stream operator, Like here we have name Sarah, we have age 28, and here we can chain multiple values in one line. We can say that the name is name, which is Sarah, comma, age, and then the age, 28. And then we flush right at the end to the console. It's also equivalent to this. Remember, without the end line, it's not flushing to the console just yet. And we'll speak a bit about that later on. But it's just important to remember that only this end line explicitly flushes the console and flushes that pipe leading to the console. Now let's look at it in a bit more detail. So as I said, end line equals a new line plus flush to the buffer, okay? So it cleans that pipe. Whereas \n is just for a new line only, not flushing the console. Now this means that whenever we actually call std_endline or the console flushes itself automatically, this happens in the background, and as you can imagine, it takes a bit of performance, right? Because it needs to collect whatever is into the console or into that pipe, and it actually needs to write that to the console itself. That is a process that takes time. So if you're constantly flushing the console after every single line or every single log in your program, it can add up and it can make your program quite slow. So what we prefer instead is just the \n, and we will let the console automatically flush itself when it's full or whenever it deems necessary. It's not going to do it after every single line. It will probably do it when it thinks it's an appropriate time, and this will make our program more performant. However, do note that this is not a rule, okay? You shouldn't always use \n, because sometimes if you're working with a video game, you might need to see that log immediately when it happens not later when the console decides to flush itself. For example, let's say you're a character in a video game and something happens in the video game that is illegal, right? This shouldn't happen. And you have a log for that behavior, but you don't flush the console instantly. What happens is that goes into the pipe, and maybe only a log comes in later on that causes it to flush the console. And now you think that that illegal behavior happened at a later stage than it actually did. Okay, this completely messes up your system and it messes up debugging and all of that. So for important logs that you need to know immediately you need to know immediately what this line outputs, you should use std_nline immediately and take that performance hit. If it doesn't matter when it's when it needs to be flushed and you're working with files, things like that, you can just use \n and have this long string or this long pipe and then flush it right at the end when you're finished to be more performant. Okay, now we briefly spoke about \n being the new line, and what \n is it's actually an escape sequence. Okay, an escape sequence character to the console. This \n counts as one character. If you hover over it, okay, well, I can't seem to isolate it, but yeah, it's one character. It's not two, even though there's a / and there's an n. Okay, it's only one character, and this is a special type of escape sequence that you can use to print that means new line. Okay, and there's a couple other escape sequences. As you can see, \n is new line, \t is tab, whereas you just press tab on your keyboard. It's 4 or 3 spaces depending. \/ is for a / if you actually want to print a / in the console, because just one / would mean an escape sequence. So yeah. \quotation is for double quotes. Okay, as you can see over here, we're putting double quotes. Again, this is because we need a way to differentiate between a string literal and an actual quotation inside a string literal. Similarly, for \single quote, this is the same for differentiating between a character like this and an actual, quotation inside a character string literal. Okay, or a character literal, my bad. \r is called the carriage return. This moves your cursor in the console to column 0. All right, that's it. \a is the bell or the beep, and this completely depends on hardware and the implementation of whatever you're outputting to, but this is usually like a little sound effect, some alert sound effect, some beep, something along those lines, okay, to indicate that the hardware needs to make a sound. We have \0, which is the null termination character, which is usually used in C-style arrays, which we'll get to later on, to indicate the end of that array, and it maps to ASCII value of 0. Okay, and here you can see there's some of them out in the console and some explanations and how you would use them. Okay, now let's say you're working with a financial or scientific, simulation type software, which is common for C++. You might need to control the precision of output in your console, and for that we can use the iomanip library, which is needed for most formatting tools. And here, for example, we have pi as a double, and if we just cout pi without any formatting, it will default and truncate the rest of the double over there. It's sort of got a default precision value, So if we want to see the full value of pi, if it's important for accuracy, then we can set the number of decimal places. We do std fixed, okay, and we set the precision to, let's say, 2 decimal places, 4 or 8, giving us this equivalent values at the end, so that we can control the precision in output and have more cleaner formatting for the user or ourselves to see. Okay, then if you look over here, again in the iomanip library, we have something called setW or setWidth, which sets the minimum width of the next output. So it's not very clear looking at this what it actually does, but basically the idea is we want to have 2 columns that look kind of equal, if I can put it like that. So I've already compiled this. If I run it, you can see that I have name, and all the names are kind of under one another, score, and all the scores are kind of under one another, and that's because of the set width right before our columns. If we were to remove this, we can compare and see how it will look then. Sorry, let me just build this. Right, then we run it. And you look, it's kind of, okay, well, I should actually, I didn't end line before. So let me just get this. We will remove this. Put end line there. Something like this. Do that. Okay, and then we need more couts. Something like this. Okay. Let's actually see how this will look now. As you can see, this is probably not what we wanted. You know, it's getting kind of hard because we end line afterwards. We'll have to put like tabs in between here. It's getting quite difficult to space them. And that's because, you know, when you're working with columns in the console, it is just difficult to align everything. So we use set width to make our lives extremely easy and have different columns for our different data. With the set width, we can also do cool stuff like set the alignment. By default, it is right aligned, as you might have picked up from the output in the last section. But we can also do std left, then do it, and it's left aligned, and we could do std right, and boom, it's left aligned. It's left aligned, sorry. And there's not a std middle. If you were wondering, it does not exist. Okay, we just have left and right, and that's it. That's all you really need in the most case for simple output formatting. And with set width, what it does is that width that we set, it will default to filling it with empty spaces to make up that width of that column. What we can do instead is tell it to fill it with a special character. In this case, we use stars, and we get an output like this. In this case, we use the little dash, and we get an output like this. And over here, we can use equals, which gives us the output like this. All of these are useful for, you know, formatting reasons, making your stuff look nice. You can use it for tables or banners, you know, things of that nature. Here's some more interesting formatting stuff from the iomanip library. We have our number of 255. If we default just print it, it prints 255. Also, you can use std for decimal, which will print it in its decimal form, which is 255. We can also print it in its hexadecimal form, which is just FF. Its octal form, which is 377. We can show the base prefix, so we can say, okay, show base. Then when we print hex, it will say 0x, as it is now a hexadecimal base, so that the user can know, okay, this is immediately hex. For octal, it's 0 in front. For des, I mean, there is no base before it, it's just 255. We can do std show pos to show its sign type. So for decimal, we can say it's plus 42. And again, for decimal output, minus 42 will just be minus 42 in the console like that. So really it only adds the plus over there, but this could be useful, you know, if you don't want to have to put in like a plus over here every time, you know, something like that. It's a bit annoying. And if you don't know what this value is, if it's a variable, then you have to put like an if statement. It's just annoying, okay? This makes it a lot easier for us when the time arises. This is just some interesting formatting additions. Here we have, again, from the iomanip library, we have some scientific notation. So we have big, here's a very big number. We have small, here's a very small number, okay? If we use std scientific, this big number will look like this with this little exponent form, which is scientific notation, of course. And small will look like this with this little exponential, you know, form added at the end, okay? Then we go back to fixed, and you will see it's this form over here where it kind of adds this long zeros, or it truncates it over here. So it's different types of formats, really. Whatever you need for your program, you can switch between them whenever the time is necessary. Now, let's finally look at the inputs std in, or cin, sorry. It stands for console in and console out, by the way, if you're wondering. Okay, let's say we have an integer age and we haven't set it, right? We want the user to set the age. So we print out to the console, enter your age. But then we use stdcin, and we use the right stream operator to age, right? And you can think of the left stream as this text going left into the console, and the right stream operator as whatever we get from the console streaming right into our variable. So we wait for the user to input something on the console. So this is where you can actually type into the console your age as a number and hit enter, and then it will actually save it in the age variable itself. Okay, just to demonstrate this, let's actually build. Okay, there we can see enter your age at the bottom. It's waiting for our input. So I'm let's say 24, click enter, and there we go, you are 24 years old. All right, that is how the cin works. And here, just to showcase, std_cin is very flexible. We have an int age, height double, initial char, and it does not care what the type is. It's just going to stream it in and try to save it. This is dangerous, but also quite nice, you know. So you'll need to do type checking yourself, because this is all allowed and we could just put in whatever we want. We can also do things like this if we have int a and b, and just do this. We have int a and b, and we ask them to enter two numbers. You can std_cin a, then stream the next input to b. All right, and then we can say sum of a and b. And to use this in the console, you will write, let's say 20 and then space, the next number 5, enter, and the sum is 25. Okay, so in this case a is 20 and b will be 5. Now we have a bit of a catch scenario with strings. Let's say we want the user to enter their name into our string name. The problem is that std_cin stops at the first space. So if you try and enter in your surname, for example, let me just showcase this. If I put in my surname of John Doe and I press enter, we just get hello John. That's not really what we wanted, right? Because it stops at the first space. It treats that as the terminating character for whatever your input is. This is an issue. How do we solve this? Well, instead of using std_cin, we can use something called std_getline, right? So here we say enter your full name, but we use std_getline. We give it the if you look at std_getline, it's got this crazy templates, you know, but really it just needs an iStream iterator and then a string, okay, which is the variable that we're saving it to. And usually when you're using the console, we are going to use the std_cin as the iterator, and then our variable of course comes second. So what this does is it actually gets the entire line, including all the spaces, up until the point where we actually click enter. So if I now were to run this program, I would get my full name of John Doe in this case. Okay, now let's look at a bit of an issue again. Let's say we have age as an int, name as our name, a string, and we ask the user to enter the age. We use std_cin age, which reads a number, but when we click enter, right, it goes to the new line, so it leaves the new line character in the buffer. This is a problem because then our next enter name, which we get the line, immediately reads that leftover, you know, next line character and just gets the empty string. So if we were to run this program, I enter my age of 24, I click enter, I can't enter my name. You see, it immediately says enter name, age, 24, and then, you know, empty name. That's really weird, right? It's not really what we wanted. So how do we fix this? Well, turns out the fix is really simple. It requires one line std_cin ignore. And what this does is it ignores one character in the stream. And all we need is that one character, which is the new line character. So after we type enter with our age, we simply ignore the new line character, which discards the leftover new line character. And then we ask the user to enter their name. We don't get the new line character, so we're waiting for the input, and it now works correctly. As you can see, we build, what's your age? 24, enter, and now we wait for the name. John Doe, enter, there we go. Age 24, name John Doe. Problem solved. Now remember earlier I said that cin allowing any type can also be dangerous. Well, again, if you ask the user to enter a number and they type in their name, you obviously want to check for that and, you know, give them feedback that this is incorrect, right? So how do we do that? Well, after this, we say enter number and we get whatever input they put in. Let's say they put in a string, right? We want to check, is that incorrect? How do we do that? We use std_cin.fail. And this checks if the input was a fail, if it couldn't save this type to this other type, right? We check if it's a valid input. And this returns true if it failed, if it's an invalid input. So if it failed, we go into this if statement and we output to the user, that was not a valid number, They must please re-enter a number. Then what we have to do is we have to clear any sort of error states within the console itself to reset it to accept a new number. And we also then need to ignore their input that they put into the console. And the first thing is we tell it, we either ignore this many characters, which is pretty big. I doubt someone's name's going to be that, or the number's going to be that big. Or we tell it to ignore up to this character, which is, the new line character when you click enter. All right. And we then go back and we handle this case, right, that they entered the bad number. Or we just tell them you entered this number and it's all good and well. So let's see how this works. If we run this, say enter a number and I type in John. We say that was not a valid number. Okay, that's bad, Again, you could have this in some kind of like while loop and looping back and asking them to type in a number, but this is just a simple example. I type in the number and it says you entered 24. Great. This is how you error check for a bad input in the console. Now we don't only get stdcin and cout, we also get stdcerr and stdclog. All right, what do these do? Well, cout is just our normal output as we discussed before. Cerr is specifically for error messages, and this immediately flushes the console, okay? Because again, it's an error message, important, right? So it's unbuffered, immediately flushes. And it's more explicit that this is an error message that you are outputting to the console. Clog, similarly, it's for logs, right? So it does not immediately flush it to the console. It buffers the logs and flushes it when it wants to, all right? And it's a bit more explicit to use clog. Now let's go over a real kind of a use case how you would use these. Okay, here we have an int age and we cout our age. Okay, there we go. We get the age, whatever it is. We don't do any checking whether it's a number or not, but you should in a real program. And if the age is less than 0, so the user entered some negative age, we use stdcerr because this is an error. And we say error age cannot be negative. This will get flushed immediately. And we return, because our main always returns an error code, as you remember from our first episode, or second, I can't remember which one. This is a non-zero, which means there was an error. We return 1, right? And that's why we use stdcerr for an error message. Otherwise, we just use a regular cout and we say age is accepted and we return the all good 0 error code, all right? These are some use cases for cerr. It just makes it more clear that this is an error that is happening in your console and it makes you look like a better programmer, all right? That's the important part. Now, I hope you guys enjoyed this video. There was quite a lot of content in this one because there is a lot of content to, outputting and inputting to consoles, to files and whatnot. And this just scratches the surface of that. So if you enjoyed the video, please like and subscribe because there will be much more content coming in the near future. If you have any questions, leave them down in the description, the comments down below, and I will respond to all of them. Thank you for watching.